Hello everyone, welcome to my talk about using NICs to create reproducible Go development environments. Customary introduction slide, a little bit about myself. My name's Haseeb Majid. I'm a back-end software engineer at a fintech called Curve, based in London. There's a link to my blog, which will also house the slides, but I'll have a link at the end where you can go and take a look at the slides in your own time. A few fun facts about myself. I really like cats, and I'm an avid cricketer. I appreciate the audience might not know what that is, but it's that weird sport we play across the English Channel when the weather's good. A couple of days a year we get. I apologize, I'm losing my voice, so we're just going to have to power through. Before we get into the talk itself, I was like, who is this talk aimed for? So I thought that it's worth going over like who my target market was. Obviously, those people who are interested in NICs. I feel like NICs has gotten more popular over the last year to 18 months. It could also just be that I'm searching more NICs content, so Google is like, here's more NICs stuff. But I've seen more YouTube videos, I've seen more people talking on Reddit, et cetera, et cetera. So I thought, people might have heard about NICs, let's teach you a bit more about it. It's also aimed at those people who are looking for more consistent development environments. So for example, like when I use the word reproducible, we kind of also mean consistent. So in the sense that if there's 20 developers working at a company and they're working on the same project, they should basically have the same versions of tooling. So if you're using a linter, you should have that same version of the linter. If you're using something to run your tests, you should have that same version. Equally, if you go and run something on CI, it should have the same version that you're running locally. So you don't want to, I'm sure we've all had issues where everything passes locally, you go to CI, it starts failing, you spend an hour or two, you're debugging, you're like, what's going on? You're losing your mind, you're getting your other developers to help you. And then you realize, oh, this has had a breaking change, or this is version 161 and I'm running version 156. So you kind of want to have that same local environment as you have in CI. Again, that's what we kind of mean by consistent or reproducible. Also, I'm sure we've all been there where we haven't touched a project for a couple of months, maybe 6 months or so. We come back to it. All we want to do is just write some code, fix the bug, write some tests, wherever it may be. And then instead, we spend a couple of hours yak shaving, trying to get our development environment set up. Oh, I need to Docker to work, I need this to work. And you're like, I just want to write some code, and here I am yak shaving. And so you basically want to find your project in the state you left it. You don't want to have to spend a couple of hours fixing stuff. And of course, onboarding new developers. I'm sure lots of us are using microservices. Like my place, we don't use a mono repo. So if you're jumping between microservices, you're cloning different repositories, you want to have a fast setup, like one command to set up your development environment, ideally. You don't want to spend run 5-6 commands. Oh, that one fails. Now I have to work out what's going on. And of course, between my company, we have some developers using Linux, some developers using Mac, and probably one or two using Windows for them. We want to have, again, that consistent environment. It shouldn't really matter what machine you're running on, right? So we'll look in this talk how NICs can kind of solve some of these problems. They won't solve every problem, but it should be able to help us. And we don't want to annoy Samuel L. Jackson, so we want our environment to kind of work everywhere. We don't want it to just work locally. So some of you are probably very fairly wondering, what's NICs? So when people typically talk about NICs, what they really mean is the declarative package manager. So when we say package manager, think brew, think apt, yum, basically anything to install software, right? Because fundamentally, one of the things we do need to do is install software, install tools to make our lives easier. You might have make, curl, wget, all these tools that you want available to yourself. There's also a programming language, which is functional, called NICs. In this talk, if I don't forget, I will call it NICslang, but it has the same name. And the reason it's important that it's functional is basically for the same inputs, we're going to get the same outputs. So essentially, that means with that same NICs code, if I share it between me or Daniel or whoever else, we're passing it the same inputs, i.e. that same NICs code, so we're going to get the same outputs, i.e. the same packages, same versions of packages, same tooling. And that's why it being functional is important, because it doesn't really care that much about the state of your laptop or your machine. It also means I jump between my laptop and my desktop a lot. So again, I can have this kind of consistent environment because I'm getting the same packages on my desktop as I would my laptop. That's particularly true if you're running the same architecture. Of course, if you're running ARM versus AMD, there might be some differences, but fundamentally they should behave the same. There's also this thing that we will reference a lot called Nix packages. It's this basically GitHub repository of Nix code, which has instructions how to build 100,000 packages written in this Nix programming language. And that's all open source. It's maintained by the community and kind of fostered by the NixOS Foundation. So you can go there, you can contribute, it's open source, you can create a package. As an aside, there's also this thing called NixOS, which some of you have probably heard about, and that is a Linux distribution which is using the Nix package manager and can be configured using the Nix programming language. It's kind of out of scope of this talk, but if anyone's interested, catch me at the end of the talk. My laptop's running NixOS, and one of the cool things about NixOS is you can kind of put lots of laptop state into this Nix code, and you can put it on like a Git repository, and it will just, you can then use that on other machines. Other people can use that. It's kind of cool. So it's essentially taking state that's usually on your machine and codifying it, which is always quite interesting. That's kind of Nix. It's kind of this ecosystem of a few things put together. But typically, if we say Nix, we're just talking about the package manager. So I used the word declarative there, and I thought it might be worth just kind of describing what I mean when I say something's declarative. When I was writing these slides a couple of months ago, I was trying to put declarative down on paper. And just as an aside, I think one lesson someone told me is if you're trying to write something down and you can't really write it down, what it really shows you is you don't know it well enough. And that was definitely true with declarative. I vaguely knew what it meant, but I couldn't quite tell you the dictionary definition. So I went and looked it up and tried to understand it. So imagine we have this Nix code. Don't worry if you don't fully understand it, but in this case, what we're trying to do is enable the Sway tiling window manager and disable the i3 tiling window manager. What we mean by something being declarative is we're just going to tell Nix to go run this code. I'm not telling Nix how to remove i3 or how to install Sway. Nix will go work that out. So the final state, Nix is going to work out the steps how to get there. I'm not telling it the other way is imperative. If we're using bash scripts, I might give it step-by-step instructions how to do that. Both Nix, I'm just saying, you go off and do that. And some of you who've been using Kubernetes, you might be familiar with this declarative approach with things like Flux CD or Argo CD. And one of the cool things about things being declarative is often we're putting things into state. It's taking things in state and codifying them. So usually, this would just be something that I've run on my machine, maybe with some imperative commands, apt, get, install, blah, blah, blah. But if I wanted to run this or rebuild my machine, I would have to type that all out manually. Whereas with this approach, this is in code. I can put it on version control. And my Git repository then kind of becomes my source of truth. So if someone goes and looks at my Nix config, they'll be like, assuming obviously I built the latest I've pushed, someone will be like, oh, this is the state of his laptop. This is the software he has installed. And then it makes it easier to rebuild stuff if something goes wrong or copy it over to a new machine or whatever it may be. And if you're one of my friends, I'm sure they will attest that eventually Nix will bust into a conversation at some point. And I think they get irritated sometimes. But hopefully at the end of the talk, you'll be able to see why I talk about Nix like I do. So to kind of summarize this first section, we want to have reproducible and ephemeral environments. And ephemeral is just a fancy word of saying like temporary, in the sense that when we're jumping between different projects, we want to have the development environment for that project, but we don't really care once we've left that project about that development environment. So we jump between them. So they're kind of temporary, short-lived for the life cycle of that project. Nix is an ecosystem of tools. It's kind of a few things put together. If you take like some of those things out of that ecosystem, it doesn't really work as well. So just kind of keep that in mind. But one thing I want to say is obviously I'm talking about how good Nix is. It's just like everything else in software engineering. It's not a silver bullet. It's not going to solve every problem you have. It adds its own complications, but it also solves a bunch of problems that we have, typically around having multiple versions of packages, and we'll see how it does that. So you don't have to worry about, oh, what versions of Go do I want? You can have multiple versions installed on your machine pretty easily. Let's take a quick look at a demo. Unfortunately, it's already started, but we'll let it run and let it reset. But essentially, this is the state we want to get to, and we're going to build this up throughout the talk, how we're going to get to that state. So once this restarts, what we're going to do is we're going to go look for this linting binary. We're not going to find it. We're going to load into this project, which is going to load into our development shell automatically. When I look for this project, this binary, it's going to be available, and it's going to have version 156.2. And then once we've left that folder, we no longer have access to that binary. And so that's what we kind of mean by this ephemeral development environment. And it's reproducible because every developer should get this version 156.2. So anyone that clones that project, has Nix, runs this development environment, it will set that up. And we're going to kind of see how you can do that. And if you look, we're not really running anything. We're going to the folder, and it's setting up that development environment for us, which is pretty cool. Like, you don't really have to think about it. So some of you are probably wondering, this is a Go conference, not really spoken about Go much. So let's talk a little bit about Go. So Go, as with most programming languages, it's not just about the tool, the code you write or the tests you write. Often we need tools around that to make our lives easier. So we saw Golang CI-lint, which I'm sure some of you will be using to lint your code. You need something to test your code, and the Go binary has obviously a really good Go test command, which does a lot. I've been also playing around with this tool called Go test sum, which is a test runner, and I find the output a little bit easier to see when things are failing. So I've been playing around with that, which is interesting. And then obviously, I'm sure many of us also use Docker in our day-to-day. If we want to run tests like integration tests, we might want to spin up some Docker containers like Postgres, Kafka, and run tests against those things running locally. So we need all of these kind of things to help us with our development, right? And again, for the reasons we've spoken about, we kind of want to have the same versions as other developers have and what's running on CI to avoid some of the issues that we've already spoken about. So one approach that the Go community here has come up with, and we use at Curve, is this tools.go file. So we create this tools.go file. We give it this build flags that kind of gets ignored. Then we install our binaries as we normally would. So let's say we're using Golang CI-lint. Here, we would just copy what's between the quotes and do go get as we would any of our other dependencies. And then what we can do is we can put these underscores here. So when we do go mod tidy, we're tricking our Go modules into thinking, oh, this is an actual dependency, so it doesn't get removed. And now these tools like Go release or Golang CI-lint, you can run those binaries doing like Go run, for example. And the versions are now managed by our Go modules, our Go mod file, and our Go sum file. And it means that when we do an update, we update it like we do the rest of our Go tooling. And that works pretty well most of the time, right? So you might, so like at work, we have like a make target that does something like this. I've trimmed some of it out so it's a bit easier to read, but we just do go run, and then I believe it should use that version made available in that go mod file. So that works pretty well, and then means when we run this in CI, when we're running this locally, we're now using the version that's maintained in the go sum, go mod files. And that's pretty good. That's a pretty good, works mostly pretty well. What happens, however, if we want to manage versions of tooling that's not built in Go? Like, for example, recently I've been working on a full stack app, and I'm using Tailwind CSS, and I need the Tailwind binary to create these, like the styles CSS file. That becomes a little bit harder to manage in Go, and I'm sure there's other tooling that's like Go agnostic that's not written in Go, and we can't take this Go run approach. That's kind of when Nix comes into things, which maybe won't surprise you in a Nix talk. So let's pretend we've got a project like so, and it's a very good project where I noticed yesterday that my testing file apparently is empty. So good on me for not writing any tests apparently. But we've got a really simple Go project here. What we're going to do is we're going to create this flake.nix file. You can think of the flake.nix file as very similar to the main.go file. It basically becomes the entry point for our Nix configuration. And essentially what we're going to do in this flake.nix file is create this development environment, which is going to have all the dependencies that developers need, i.e. tooling that developers need to get started, like, to run linters, to run SQLC, to generate code, whatever it may be. So don't worry if the syntax is a bit confusing. This is more like high level. We're now going to take a look at some Nix code. And you can go through in your own time and take a look a bit closer and try and understand the syntax. So essentially with our Nix flakes, we have two things. We have inputs, outputs. Inputs are typically going to be Git repositories. So here we have two inputs. We have Nix packages, which is that repository we were talking about earlier, which houses the code to build 100,000 different Nix packages. It's like kind of recipes you can think about. It's like builds. How do we build these packages with Nix? We've also got this other input called flake utils, which is mostly just a helper, just to help reduce some code, some boilerplate. Then we have a section called output, and this is what we're going to output from our flake. One of the things we're obviously going to output in this case is a development shell, but with Nix, because it being a package manager, you can also output a package. Funnily enough, you can also output stuff like a Docker image. You can build a Docker image with Nix, which is a bit weird. Conceptually, I understand, because most people think you need a Docker file, but that's not necessarily true. You can also output some other weird stuff. If anyone's into home labbing, you can kind of create a home lab with Nix, and there's this tool called Nix topology, which lets you, from a Nix flake, lets you output these SVG diagrams. So if you've seen some of those fancy home lab diagrams, it can generate these SVGs as well. So you can even output images, but it all like, but but it all depends. Anyways, for the sake of this talk, all we really care about is outputting development shells. So as you can see, in our outputs here, we've specified the inputs, which we can then use. Again, flake utils here is just this helper library because we need to build this flake for different architectures, referred to there as a system. So for example, my machine is x86-64 Linux. Some of you may be running Macs, and I think they're like AArch64 Darwin machines. So rather than me needing to specify all the architectures this could work for, and then you guys, when you build it, need to specify your own architecture, flake utils just kind of works that for us, the system variable is like automatically filled in with the architecture. So here, what we're doing is we're going to create this packages variable, which is going to be related to the system architecture, because of course, how we build stuff will vary depending on if we're on AMD or if we're on ARM, et cetera, right? Like the architecture changes that. Then on to the really interesting stuff. What we're going to do is we're going to output this development shell. If you look here, packages, you can kind of think of this variable as an object. I know functional programming is not really an object, but Go related, you can think of it like an object. And it has a function called makeShell, which will create our development shell. We pass it a bunch of arguments. In this case, we're just going to pass it one argument, which is the packages we want available in our development shell. And then we're just going to give it a list of packages we want. We can even specify the Go versions. If we want to, for whatever reason, lock our developers to using Go 122, you can go and do that. And then all of these tools will be made available. And some of these tools may have multiple binaries, like Go tools has a bunch of binaries inside of it. But yeah, so that's kind of our flake.nix file. If we save that, how do we actually use it, right? So again, if we go to our classic example of doing which Golang CI lint, we don't find anything because it's not installed globally, it's not available. What we then do is we run nix-develop. Nix-develop, it sees that we have a flake.nix file, and it's outputting this development shell. And if you recall, we gave it a default name. We called it default, so we didn't give it a name. So it's just going to run that default one. It's going to create the development shell. It has a bunch of output that I'm not showing you just to keep it relatively simple, but we're going to load into our development shell. If you can see just above it, I'm using Starship prompt, and so you can kind of see it says I'm in this impure shell. But when we do which Golang CI lint, we now see we can find this Golang CI lint binary in this funny little path called nix store, and we'll see why things are put into nix store with this funny path, but we can see version 156.2. And then this will also create a flake.lock file, which you can think of very similar to a go.sum file. It's locking our dependencies. We can then commit the flake.nix and flake.lock file, put that into version control, i.e. Git, and then other developers can pull that and run this development environment as well, which is pretty nice, and we should get the same versions. They should get the same version of tooling as we have available. So that's kind of our rough development environment we've created with Nix. We've created our first one. Just as an aside, like you can do Go run, you can also do Nix run. So if you have a flake that's outputting a package, so this is a tool I built with Go, a CLI tool, just to make my life a bit easier for searching for Nix options. It has a flake.nix, and it's exposing a package. So when we do Nix run this, and it's available on GitLab, and then we parse it this get no 2e options, which are command line flags and arguments passed to the binary itself. It will actually just run. It kind of runs without installing. So that's kind of nice. So similarly, as you can do Go run, you can also do Nix run. And you can run a whole bunch of stuff without installing it. And then you can see this is the output of the package itself. So I appreciate throughout this talk, you're probably going to get a lot of information. So I'm going to try and summarize each little bit as we go through. So we can leverage dev shells for installing packages. Once we've created this development shell with our Nix flakes, we can load into them using Nix develop. We can make sure each developer is getting the same versions of packages because we have this flake.lock file. And we will explore a bit later how the flake.lock file locks our dependencies. But if you're thinking go.sum or poetry.lock or package.lock JSON files, it's a very similar concept. But yeah, and those versions will be exactly the same until we do a Nix flake update. So some of you may be thinking, hey, at the beginning of the talk, when you showed us that demo, you automatically loaded into the shell, and now you're running Nix develop. Well, how I did that was we used a tool called direnv. Direnv is agnostic to Nix. There is a Nix fork, which adds a few nice things, like it will cache your development shell, make sure it's not collected by the garbage collector and deleted by accident, so you don't have to keep rebuilding it. But generally speaking, direnv is this agnostic tool. And what direnv allows you to do is as soon as you go to a folder, it will run some code that you've put in this mvarc file. So in our case, what we're going to do is we're going to create this, I don't know how well you can see that, but we're going to create this .mvarc file, and we're going to put in useFlake. UseFlake is just this helper function that will essentially call nixdevelop for us automatically. And if we take a look at an example, this might be a bit easier to follow. So we've got which Golang CI-lint. Again, our classic example. Again, we don't have it globally installed, so it's not available. Imagine someone's just cloned one of my projects, Banterbus, and they CD to it. They go to it the first time. direnv will be like, hey, I'm not just going to run whatever's in this, because you could just be running arbitrary code on your machine. So it says you need to allow me to run. And so that gives you time to go look at the mvarc file, look at my flake. There's no shenanigans going on. OK, I like this. Then you do direnv allow. Direnv allow will allow direnv to run. In this case, obviously, we've passed it useFlake. So useFlake will then run, which will load into which will just basically run nixdevelop. In this case, there was nothing for it to do because the shell, the dev shell was already cached. And then if we do which Golang CI-lint, again, we get that version that we expect, and it all works pretty good. Once we leave that folder, we can see direnv says unloading. And if we do which Golang CI-lint, very sad, we can't find it. Just note that direnv allow, you only have to do it the first time you clone that project, or if the mvarc file changes, but we are not typically touching it. Like this project I've had for 9 months, I've never touched the mvarc file after setting up. But if I went back to that Banterbus folder, it would just load that development shell for me automatically. And let's say the flake.nix or flake.lock files change and I pull them, direnv is smart enough to just run again and run our new development shell for us. So it's pretty cool. Like you don't even have to think about it. Another thing, kind of extending on from that nix run example we saw, you don't even need to point your direnv mvarc file to a local setup. You can point it to something on GitHub. So this is a repository with a bunch of tools for different languages to help you get set up. It's like templates for different languages, Rust, Go, JavaScript, whatever it may be. So I've pointed it to the Go one. So if you're, like, again, if you're perhaps using microservices and you don't want to add the boilerplate of every project has a flake.nix or a flake.lock file, you can just create a repository and just point it to that and say, all of our projects are just going to use these, and it's this one place that we're going to go. So that's kind of cool as well. Adding on to our DevX developer toolchain, I want to talk to you about adding pre-commit. So as some of you may be aware, when you're using Git, there's these things called Git hooks. And essentially what they allow you to do is kind of run arbitrary code or shell scripts at different stages of the Git process. So before you push your code, you can run stuff. After you push your code, pre-commit, post-commit, et cetera, et cetera. Typically, most tools that help you set up Git hooks will run stuff just before you commit your code. And if those scripts fail, it will stop you from committing your code, right? And the nice thing about that is you can run things like linters, formatters, or testing. And if any of that fails, you get some really fast feedback as a developer. Now, there's this tool called pre-commit, which I think is not necessarily named the best because pre-commit allows you to create pre-commit hooks, which are basically these Git hooks we were just talking about. And there's a wrapper around Nix that the cache hooks have made. And we can set up pre-commit in Nix as well. So let's take a look how we can do that. So we add another input, as we have done. So this is our flake.nix file. We add this pre-commit input. We go down just under our packages variable. We create this other variable. We pass it the system. It has a few built-in hooks. So we can enable the linter, and we can enable testing. You can also create custom hooks if you want. And it's open source, so you can go and add your own hooks. So I've added some hooks around formatting code that you can use. And these will only lint the codes and test the code files you're trying to change. So those files you're trying to commit, it will run the linter only against those. It won't run it against every file. So that's kind of nice. You just get feedback about stuff you're trying to change. The final thing we want to do is we want to do this, add the shell hook argument to our make shell function here. And in this case, we're just going to use the pre-commit shell hook. And a shell hook is just some code that's going to run as soon as we load into this development shell. It's just like a bash script. We could equally write echo hello world, and every time we'd load into that shell, it would run hello world. One of the reasons this is quite nice is those of you who've used pre-commit, you need the pre-commit binary installed, but you also need to run pre-commit install the very first time on a project to set up your pre-commit hooks. It will actually create the files in the Git folder. So again, that's another command you kind of have to remember to do. But in the Nix world, as soon as you've done direnv allow, it will set up those hooks for us. It will set up all the packages for us. We can even make some of those binaries from the pre-commit stuff available as well if you want to. So it's pretty nice. And it's just reducing the things we have to think about. And then if you're like me, you're committing your code and you've forgotten to run linters or testers, as you start committing your code, you do git commit. It will automatically run those scripts for us without you even having to think. So to kind of summarize this section, we can use direnv to further reduce cognitive load. So we don't even have to run nix develop, but direnv is just doing that for us. We can even use create dev shells from remote Git repositories. It doesn't need to be local files. And we can manage pre-commit in Nix as well. But one thing I want people to be aware of is just note that pre-commit is its own thing. And if you're not so familiar with pre-commit, it can be an issue jumping straight into Nix, because now you have to learn how pre-commit works, and you have to learn then the Nix way of running pre-commit. And some people just don't like running abstractions. Right, like this is an abstraction on the tool, because essentially it's just generating the same YAML file that pre-commit does, but it is an abstraction. Some people just don't like that. So just keep that in mind. I don't necessarily mind it. I kind of like managing all my devexy things with Nix and having this kind of one line setup, but some people might not like that. So in this section, let's take a quick look into the Nix syntax and what's kind of happening behind the scenes. Again, don't worry if like some of this is confusing. It's not like the most straightforward stuff. Again, you can go and look at some of the stuff in your own time. But essentially, let's imagine, oh goodness, you absolutely cannot see that. I've called this file shell.nix. Let's imagine I want to split out our dev shell and I've moved it to another file, right? So you can think of these files as kind of functions. So when we import this file, we're going to pass it a bunch of arguments, right, in our flake.nix file. And one of the arguments, the only one it really cares about, is this argument called packages. You can just think of this as a Go function, you know, format. If you're using like format print line, you're going to pass it a string. That's what it expects. And it's similar here. We're just expecting a variable called packages, which is similar to the packages variable we've already seen. And then we have this triple dot syntax to ignore any other arguments passed to it, because I believe otherwise it would error if you pass some extra arguments by accident. But here we're saying, oh, we don't care, ignore them. Then we have this packages make shell function again. So packages has a bunch of stuff. Again, I know if you're functional programmers, I'm going to upset you by saying it's an object, but you can think of it a bit like an object. And one of the things the object has is a function. Then we have a list of packages that we want it to install. And essentially, in Nix, what we're essentially here is what it's going to output. Is it's going to output this attribute set, which you can think of a bit like a map. And what the attribute set is basically just going to say, it's a special attribute set because it's going to give it a set of instructions of how to build packages, right? Essentially, all we're telling Nix is we want to have these two packages installed. And that's what's going to be output. If we go back to our flake.nix file, if we want to import the shell.nix, it looks a little bit like this. And then if you look there, we've got the curly braces, and we're passing it that packages variable that we said it needed as an argument. And this will still work. We can still do nix develop. direnv will be able to do its thing. That's a little bit about the Nix syntax. Some of you may be wondering, what about how can I look up what packages are called? Well, unfortunately, it's got cut off at the bottom. But there's a website called searchnixos.org. You can go there and search for websites, search for packages on that website. So if I type in Go, these are all the things that start with Go. And then if you're interested and you want to see how Go is built with Nix, you can press that source button there. And then we can take a look at some of the Nix code of how to build Go. And with most Nix expressions, or Nix code, what you'll see is we have the standard env make derivation function. And we have some other stuff, you know, where to fetch Go from and a bunch of other stuff. Derivations are basically one of the key building blocks of Nix. Right, and we'll see why that's the case. So this make derivation function is, I think even in the documentation it says it's the most important function in Nix, most important built-in function. So building in Nix is a two-step process. At evaluation time, the Nix expression, or the .nix file, is passed, and we return a derivation set, or a DRV file. So it's kind of this intermediate state, or intermediate representation of how to build a package. Then at build time, the derivation is built into a package. I believe this process is also called realization. Not 100% sure on that one. Anyways, it's important to note that this is a two-step process. Typically, you will be doing this as a one-step process, as in you'll be using like Nix build or Nix develop, and behind the scenes, it'll be doing this for you. So if we take a look at some derivations, Derivations are put into Nick store. So once we've built a derivation, this is what they roughly look like. They have a hash, a name, and a version. So if we take a look at one for Go, we can see Nick store has this funny hash. It has the name of the package Go, and then the version of the package. And where that is really important is basically the hash there is any of the inputs, as in that Nix code changes, we get a completely different hash. So even if we just change one environment variable, let's say we're turning a Boolean 0 to 1, for example, you get a different package as far as Nix is concerned. You get a different derivation, and from that derivation, we're going to get a different package. And so essentially, once a derivation is built, it's immutable. Once a package is built, it's immutable. Now, this is only a Nix store. You can kind of do what you want. You can go delete stuff, you can change stuff, but it's highly, highly recommended you don't do that. As far as the user is concerned, once a derivation has been built, we know all the inputs. If any of those inputs change, it's a different package as far as Nix is concerned. So if we take a look at what derivation looks like, so this one for Go, we can see it looks a bit like a JSON file, actually. We have a builder, so this is like to bash how we're going to build it. We have a bunch of environment variables, and these are the only environment variables that are going to be made available during the build. So we've declared everything that's going to be made available. It's going to be fully sandbox, and we know that there's not going to be any extra environment variables accidentally injected. So that's pretty nice. And again, it's taking this input from that Nix code we've seen here in this DRV file. We then also have a bunch of input derivations. So these are other derivations that we depend on and need to be built into or realized into packages before we can, before Go can be built. And then finally, we have some metadata. Particularly this out path string is quite important because that tells us where we're going to build the package. So some of you may be wondering, what's the advantage to this approach? So there's a couple of advantages here. As I've said, derivations are immutable. And if you look, once we built the Go package here, we can see it's at this funny Nix store path, blah, 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 and then bin Go. It's not put into things like user local Go, user local bin, or bin. Nix gets rid of the file hierarchy standard to a certain degree. It doesn't use it. And that can cause problems sometimes with some binaries. There are workarounds to get it working in Nix, but Nix basically just throws that away and says we're going to do things our own way. This binary will get symlinked somewhere in your path variable so you can use it. But just note that where packages are stored is completely different to most other Linux distributions. But basically, essentially, what that then means is we can have lots of different versions of Go installed, even the same version, but if it has a different input. The derivation is immutable, and the package that's built from that derivation is immutable, and we never touch it. If we want to edit anything, it's a new package, and then we can symlink and point to that new package if we want, depending on what project we're in. Another advantage is we can leverage binary caches a lot. So one of the things that Nix does is it's constantly kind of building these packages in these machines. And we can go and reference those machines as a cache. Because we know that packages are now mutable, and once we have the out path, and we know the out path, well, the derivation can look on our machine and say, oh, that package already exists, don't need to build it. Or it can go to one of the caches and say, hey, can I just download this? Because it's already pre-computed. And we know, because of the reproducibility that we've just spoken about, that's immutable, that we know it has to be exactly the same package that we want to build. And so then we can just copy those files across, and that works pretty well. And so you can see here, when I'm building Go, I'm downloading it from the official cache, which is pretty nice. One of the other things it forces us to do is make our dependency tree very explicit. So our Nix store basically becomes this acyclic directed graph. And you can see dependencies, and dependencies are dependencies, and they're all listed out, and they're all like there for you to see. One other advantage is now when we're doing updates, they can be atomic in the sense that if your machine shuts down in the middle of an update, it doesn't really matter that much because we're not updating packages in place. So because we're not changing user local Go anymore, or user local bingo, we're updating them in Nix store, and then we have this Nix profile bin folder, which is made available in our path variable. And what Nix can do is once all the updates are done, it can update all these symlinks at once. It doesn't have to do them one at a time. So it kind of becomes atomic. If that fails, it can revert back. If an update fails, it can revert back to an older version. If you're using NixOS, you can also leverage generations. So you can go to older versions if you break your machine, which is pretty nice. Some of you may also notice that we have an epoch time of 1 here. So 1970, 1st of January, and that's because sometimes the timestamp is embedded into the binary, and essentially we want to be deterministic about what the binary is going to be built. If the timestamp is embedded, you're going to get a different binary, so we hardcode the timestamp to always be this epoch time of 1. And in the Nix world, this is what bin cats looks like. Maybe not as elegant, but there you go. So to kind of summarize, derivations are key building block of Nix. Nix derivations allow us to have immutable packages. Very quickly, just going and taking a look at Nix flakes. Why Nix flakes are important and how they fit in is essentially they take state from our machine and codify them. So before we would have these things called Nix channels, where you'd be pointing to a specific version of Nix packages, but that would be really hard to synchronize between machines and between developers. Now we're taking that and codifying that and putting that into a flake.lock file. So if we take a look, this is again our flake.nix file. We have this input. If we take Should I just carry on? Cool. So we've got a nar hash. Can you guys hear me still? Cool, perfect. So we've got a nar hash, which is a hash of the contents, because sometimes we won't have. Because we won't have necessarily always be Git inputs, but they typically are going to be Git inputs. So what we more care about is this revision, which is again this git sha, git hash commit, and essentially we'll be pointing to this specific version, and that means every developer, because we're going to commit this flake.lock file, will be looking at that same version of Nix packages in this case, and it will have specific instructions of how to build stuff. And until we update that lock file, we won't update. We'll still be building Go 122, for example, and maybe once we've updated, it'll be building Go 123. But we want to do that, and we're pretty happy. It's like an explicit thing you are doing yourself, and you can do this on a per project basis. So to kind of summarize this, thank you. Nix packages improve reproducibility by locking our dependencies. They provide a more standard way to configure our Nix system because they kind of become, flake.nix becomes the main.go file. But they still are an experimental feature, so there could be breaking changes. There could be a bunch of stuff that doesn't quite work out. So just keep that in mind. I feel like they've been adopted by a decent portion of the community, but just remember, because they're experimental, there's no guarantee of behavior not changing. Very quickly now, I want to just talk about CI. I appreciate, again, there's been a lot of information, but I'm going to show you kind of two approaches to CI, and we're going to kind of blitz through this. But we've spoken about things working the same locally. How can we do that in CI? Well, if some of you may be familiar with GitLab CI, but I'm sure this will be applicable to other other CI runners as well. We're going to use the official Nix image. And if we take a look, the interesting thing there is we're going to do Nix develop and then do task test unit, where task is very similar to a make file. It's just running our unit test for us, right? And then if you take a look at what it's actually doing, it's just running everything that's not an integration test, and that works mostly pretty well. However, when we actually go to CI, what we're going to see is, yes, we can leverage the cache, but if you have jobs, if you have like 5 jobs running at the same time, like linting, formatting, testing, all of them are now going to be copying from the Nix and copying basically the same dependencies. Similarly with Go, though we could have fixed this a little bit easier with Go, I noticed that a lot of my jobs, this worked pretty well, and it wasn't that slow, but I just noticed most of the time was spent downloading dependencies. There's a few ways around this, but they were not like straightforward. So I want to kind of take you through this second approach I used very quickly. So this is a ci.nix, right? Imagine we create a new file. We're now going to build a Docker image with Nix, which again is kind of weird because you always think you need to build a Docker image with Docker files. But because we've spoken about the reproducibility of Nix with Nix store, what we can just do is build those packages and copy them over as layers to our Docker image. And so again here, we give it a bunch of packages, some core packages that GitLab needs, like git, curl, bash, et cetera, et cetera. Then we're going to concatenate it with this dev packages variable, which will be those packages we want available in our dev shell, in our Docker image. So if we go back, we'll create this new dev shell packages variable, which will be very similar to what we saw before. And the main reason we're creating this variable is just so we can share packages between our development shell and our Docker image, so we can just change it in one place. Then we can update our flake.nix file so it looks something like this. Again, don't worry super about the syntax, but just note we're exposing a package now. Then in CI, we can go back and we can do Nix build, and we can target that CI, which is what we just called it. We called that Docker image. We give it a target of CI. Then we can do Docker load, which will load this because it's actually a tarball, so we want to load this as a Docker image. If we did Docker images, you could see that it's loaded that as a normal image now, and we can push that image to our GitLab registry or any Docker registry. as we would. And then kind of finally, we create this private job, which is essentially just here reducing a bit of boilerplate. So we specify this image we've just pushed. We specify a bunch of things so we can leverage caching our Go dependencies, because they're probably going to change a lot more than our development dependencies will in terms of like dev tooling dependencies. So, and they're pretty quick on the cache in GitLab, so that they work pretty well. We can add a job to download our dependencies and update the cache if our Go mod or Go sum files change. And then finally, our unit test job looks something like this. We extend that previous kind of private job we saw, and we just run tasks test unit. And we got a pretty nice improvement there of 1.5 minutes. This is rather arbitrary. I just ran this 10 times on my own GitLab runners. But yeah. And this was definitely me when I first heard about Nix. I was like, I don't really get it. I don't understand. Hopefully, some of you will use it and start to understand. And kind of final thing, why not Docker, specifically Docker dev containers? I'm sure some of you are thinking. Main reason is I find them hard to personalize. It's really hard to like add your own tooling into it. And then final thing, if you wanted to try Nix, here's my kind of 3 steps to get started. Use the determinate systems installer because it comes with a really nice mechanism to uninstall. Hopefully you won't be uninstalling, but it's there. You can go to this dev templates repo, which will help you get started with some examples. And then you can install derenv Nix temporarily. And I think they roughly map to these 3 commands here. There's a bunch of stuff that you can read in your own time. I've got like a YouTube video here where I go more in depth about how I set up my development shell. I'm going to show you, there's a link to the slides and the blog post, so feel free to go through those links at the end I just blitzed through. And that's basically it. Thank you very much for coming to this talk and listening. Hopefully you found that somewhat useful.
You got a question? Oh, okay. Go on. Yeah. There you go.
Thanks for the talk. I have a question. How does it work with development environments like VS Code? I mean, if in my VS Code I lint with VS Code, so how VS Code picks up this environment and that it stores this binary in a different place on the system?
That's a really good question. I don't use VS Code, but I believe there was like a direnv plugin for VS Code, so it would load this development shell. And I believe it depends on how your path variable is set up, because I think when you run which Golang CI lint, for example, right? I don't know exactly how VS Code works, but I imagine it's just picking up. It doesn't have its own version; it's just picking up from your path variable. So if Nix store is, I forget which way path works. If it's the first one it finds, I think it is. So if it's close, if it's the first one it finds, it will use the Nix one. Obviously, if you don't have it installed anywhere else, then it should, I believe, just pick up and use that binary as it normally would. But I haven't done it, so this is just me guessing off the top of my head.
Thank you.
Yeah.
Are there any other questions?
There's one.
Oh, yeah. Sure. There you go.
Thank you for the talk. Nix has been for a long time indeed in my kind of viewport for development environments, but it always felt like it was trying to solve way more than just development environments.
It is.
Yes,
yeah.
which is not really the unique kind of philosophy of approaching it. But I have a question for you that compares this to those tools that are trying to focus on one problem of managing your development environment, like things that are managing their version of your tool version files. I'm sure you probably ran across them, which are allowing you to just define declaratively which versions of the environment you want, and they will take care of installing them, probably downloading the binaries that have been pre-built instead of trying to build them on your own. So in your opinion, what would be the biggest advantage and disadvantage of Nix compared to those tools?
So one thing is, I think it tells you that Nix is quite complicated because there's like 3 tools I can think about which leverage Nix but try and abstract Nix away. So you've got devenv, as in devenv, dev environment. You've got devbox. You've got flakes, and I think flakes, I don't know if I'm pronouncing that right, like literally just hides all of the Nix details. So you can basically do, as you were saying, I think with devenv, for example, you can even do like process. It has something called process compose. So rather than Docker compose, you can run stuff as processes. And again, it's all kind of managed in this nice YAML format. You don't have to learn another language. And those work pretty well. And actually, as a jumping off point, those are probably also good if you don't want to get involved with Nix. The biggest disadvantage with Nix is it's complicated and it's another tool you need. So imagine, like I haven't tried to really push this at work because every developer now needs Nix installed on their machine, really. And you need like buy-in from a few people, right? So that's the thing, it's complicated. You kind of have to learn this other language. And especially if you're not super familiar with functional programming like I wasn't, it can be really confusing. I think the biggest advantage with Nix is its flexibility. Like the fact you can build a Docker image with Nix is really weird. Like when I first heard that, I was like, oh, I thought you could only build Docker images with like Docker files, right? So that I think that's its biggest advantage. Is the syntax for it is really quite flexible, so you can actually do a lot. But if you just want a development environment, then maybe yeah, devenv or these other tools are the way to go. I don't know how well they would then work on CI, but I guess if you did something similar where you just built a Docker image and made sure those exact versions are available, and you have a way to kind of make sure that's the case, then yeah, it probably works pretty well.
Okay, any other question?
So it seems that you invested time in your dev environment, but your other colleagues are not using the same stuff.
So I'm just using Nix for my own personal projects.
Okay.
I haven't really used it at work. I've used direnv a little bit, like to do cheeky things. Like we were doing something with GitLab and Backstage, and I needed some secrets. So I was just like injecting them, and direnv was loading them automatically for me, and I was making sure that file wasn't committed. But that's about as far as I got with my Nix development environments at work. Yeah. I don't use them.
Yeah, because usually I think that most of the time, people, when they're trying to do something, they invest time like to make the dev environment closer to the production environment. And I don't see how this is going with Nix directly, like for the...
Yeah, I know, absolutely. And I think the thing basically is I think with Go especially, we're quite lucky because I think a lot of people, if you're deploying stuff on Kubernetes, you essentially probably are just building a scratch image. Essentially, at the end of the day, you're probably just building a scratch image and copying stuff over. So I'm not as fussed about that. But it was more around when you're developing, you need certain tools that you want available. And I just wanted, especially because I work in like a DevXE role at work, and quite a few times I've spent a couple of hours debugging something, and it just turned out to be like a version issue. Mm-hmm. And so it's like, let's just make sure at least the local and CI environments where we need this dev tooling, you know, to create coverage reports and security reports and all of this stuff, at least the tooling is made available. Yeah. And one of the issues we've had at work is sometimes people can't run stuff on CI. Mm-hmm. Like, so stuff that's run on CI, they just can't run it locally. So if you want to make sure that the coverage report is being generated properly, they can't. Easily anyways, they have to go look at the CI file. And so when I was working on my personal projects, I was like, everything I can do on CI, I want to be able to do locally.
Yeah, that
makes sense. So you're right, it's not concerned with production, like making it the same as production.
Thank you.
Okay, any other question? I think that's it.